Welcome to Spring LIB.
Okay, so we're doing chapter 29, problem 55. So in this problem, we have a big wire here, and it's carrying a current I naught uniformly across the whole wire, and it has a radius big R. So what we want to figure out here is we want to calculate the magnetic flux through a particular rectangle running through the center of the wire. So to draw that, let's look at a top-down view of the wire and assume this is like infinitely long. Here is the center axis of the wire. So this being the radius, big R. So what we're going to do is we have a rectangle of width, big R, and length, big W. And this is along there. And we want to figure out what is the flux through just that rectangle. Okay? So to first do this, we know that the magnetic field depends on R while we're inside the wire, and we can look back to the last chapter, actually at example 28.8, and we'll see that the magnetic field inside of a wire is dependent on R, such as U naught I over 2 pi big R squared linearly in R. Cool. So now, if we know that the magnetic flux is changing as we go, we can write the differential out as B of R times the area is also changing as we go through this, and this is W times dr. To illustrate what this is actually meaning, let's draw this wire again. So here's our square here, it's big R. So what we have is, imagine we're just cutting out this tiny little rectangle that is R away and of width dr, and this is what we're left with. So it's width dr times the length of W to get that area times the magnetic field B of R. So if we plug all this in, we see this comes out to U naught I W over 2 pi big R squared R dr. So if we want to find the total magnetic flux through this rectangle, all we have to do is integrate with the correct bounds. Oops. Okay, and we know we're going to be integrating with respect to R, so let's just go ahead and plug this in, and we see we pull out our constants out here first. And this is the integral. We're going from 0 to big R of R dr. Cool. So we can just do that integral pretty easily and see that the answer is U naught I W over 4 pi. Perfect. That's it.